Module 9.9, Just Intonation and Equal Temperament. In the last module, we learned about some of the problems presented by the Pythagorean scale. Historically, the Pythagorean scale was used from about 500 BC until the late Middle Ages. Because of the dissonance of the interval of the third in the Pythagorean scale, most music used either just melody or very simple harmony. With the availability of non-fretted string instruments, as well as the voice, where pitch could be adjusted on the spot, composers started writing music with consonant thirds and sixths, and fixed-pitched instruments started to be tuned to a system called just intonation, which replaces the Pythagorean ratio of thirds and sixths with ratios of small integers 5:3 for the major sixth and 5:4 for the major third. This system was initially codified by an English Benedictine monk and mathematician named Walter Oddington in the early 1300s. When pitch is adjusted to just intonation, the sounds of thirds and sixths, as well as fourths and fifths, are very pure. The harmonies are clear, and there is no beating or roughness. Here's an example of Frere Jacques in just intonation. Now here it is in Pythagorean. You should have noticed that in the second version, when the two melodies played together, that the sound was rougher. So with just intonation, all is good in the intonation multiverse. Or is it? As long as you're in one key, just intonation works very well. But if you decide to go to another key, harmonic mayhem begins. All of those nice small integer ratios start to go away. Some of the changes in frequency are so large that even a melody is affected. Here is Frere Jacques transposed to the key of C sharp. As the tuning was for C, not C sharp, you should notice two things. First, the melody sounds out of tune, and when the harmony begins, it becomes very dissonant. As just intonation had its advantages and disadvantages, other temperaments were created and used throughout the 1800s. Because of the shortcomings of these temperaments, composers tended to only compose in keys that sounded good and avoided keys that did not. The desire to compose in any key got greater, and in the late 1500s, several music theorists and mathematicians began proposing a system that would work in all keys. This temperament, allowing all keys to have the same harmonic character, is called equal temperament. It became prominent starting in France and Germany in the 1750s and eventually in England in the early 1800s. In equal temperament, all semitones have equal frequency ratios equal to the 12th root of 2, which is 1.05946. This allows musical instruments to change keys easily. The trade-off is a slight change in the quality of the interval harmony. There are several videos with demonstrations of the differences using real instruments and music of famous composers in Blackboard. We will investigate the differences of Pythagorean, just intonation, and equal temperament in the lab. To review, just intonation adjusts the frequency of thirds and sixths in the Pythagorean scale so that they are ratios of small integers. The advantage is that chords played in the key that has been tuned are very smooth and consonant. The disadvantage is that some of the harmonies are dissonant if you play in other keys. Equal temperament adjusts pitch frequencies so that all semitones have equal frequency ratios, equal to the 12th root of 2. The advantage is that all keys have the same harmonic qualities. The disadvantage is that the harmonies are not as pure as with just intonation.